What does real cosmic power feel like? Picture the universe as a quiet, endless stage. Some things don't just sit there, they rule. Meet TON 618. From more than 10 billion light-years away, it shines like a lone lighthouse from the universe's childhood. At its heart is an ultramassive black hole, about 66 billion suns packed into one gravity monster. Its story didn't start with fireworks. It started as a tiny smudge on a photoplate. Back in 1957, the Tonant Scintilla survey logged it as a faint blue dot, number 618. For years, nobody guessed what it really was. Just a point of light. Nothing special, or so it seemed. Then astronomers read its light, and the secret spilled out. The wavelengths were stretched deep into red, not from simple motion, but from the expansion of the universe itself. That told us the light had been traveling for over 10 billion years. TON 618 wasn't a nearby star at all. It was a quasar, a brilliant beacon from the edge of the observable universe. We never see the black hole directly. We see the chaos it causes. The quasar's glare is so intense, it can outshine the Milky Way 100,000 times. What makes that glow? A brutal engine of gravity. Gas, dust, even stars spiral into a disk and heat up to mind-bending temperatures. As the material whips near light speed, friction and magnetic storms turn it into blazing plasma, blasting ultraviolet and X-rays. That radiation pushes outward, while gravity pulls inward, balancing near the Eddington limit. The brightest a thing can shine without blowing itself apart. TON 618 lives right on that edge. Not everything falls in. Twisted magnetic fields act like cosmic railguns. They grab a bit of the inflowing matter and fire it out along the poles, relativistic jets that slice across millions of light years. Those jets dump enormous energy back into the galaxy around it. How big is 66 billion suns? Try this. If our sun were a grain of sand, the black hole at the Milky Way's center would be a bowling ball. M87s? A bus? TON 618? Think a mountain more than a mile high, crushed into a point where density goes off the charts. Its event horizon, the no-return line, would be so wide it could swallow our entire solar system, past Pluto, out to the Oort cloud, and still have space to spare. It's a shadow big enough to hold thousands of solar systems. So how do you weigh a monster you can't see, from 10 billion light-years away? You study the fingerprints in its light. Gas clouds race around the black hole at insane speeds. Light from gas headed toward us shifts blue. Light from gas racing away shifts red. The pattern tells us how fast everything's moving. Those sharp spectral lines get smeared, broadened by the motion. The width reveals the speed, up to about 7,000 kilometers per second. Combine that with the size of the gas region, estimated from changes in brightness, called reverberation mapping, and you get the mass. The math points to many billions of suns, one of the heaviest black holes ever measured. Getting close would feel like physics breaking. As you fall, time stretches. Minutes for you could be years, or centuries. For someone far away, gravity would stretch your body into spaghetti, literally. Your last light would slow, dim, and seem to freeze right at the event horizon, stuck there forever to outside eyes. But why should we care about one far-off monster? Because ultramassive black holes shape their galaxies. The radiation and winds from a quasar like TON 618 can heat or blow away the cold gas that makes stars. That feedback can shut down star birth and rewrite a galaxy's future. And here's the big puzzle. How did something this huge appear so early? Did it start as a ridiculous first-generation star and grow non-stop? Did a massive gas cloud collapse straight into a black hole? Maybe runaway galaxy mergers stacked mass fast. Solving this tells us how black holes and galaxies grow together. We're building the tools to find out. The James Webb Space Telescope and the next generation of giant ground observatories can peer into the universe's dawn, track the first quasars, weigh their shadows, and watch how they sculpt the cosmos. Here's the paradox I love. The darkest objects light up the universe. Their appetite writes lines of light across billions of light years. TON 618 is our benchmark for just how big, bright, and bossy these engines can get. Soft. This is gravity's handwriting, elegant and relentless. And as we look deeper, past distance and time, we know more quiet giants are out there, waiting to be found.